Hey Geometry team, and welcome to Unit 5, Day 2. We are moving on with our right triangles and going on to special right triangles. So before we used the Pythagorean theorem to find the lengths of sides of just any old right triangle we had as long as it was a right triangle. Now we're going to move on to some special right triangles that have certain angles in them that we don't even need to know two sides to find the third. So let's get started. And if my mouse will go ahead and click it. Come here, mouse. There we go. So our first special right triangle is one that is 45, 45, 90. So the 90 tells you we've got a right triangle here, and this one's down here. Now, since it's a right triangle, if this guy's 45, this guy has to be 45 to add up to 180 degrees. And so any right triangle that's got one 45 will have another 45. Well, if you remember from our corollary to the base angles theorem, is that if these two angles are congruent, that automatically means that these two sides are going to be congruent. So if you know one of the sides opposite a 45-degree angle, you know the other side opposite the 45-degree angle. So if this guy is 10, this guy is 10. Seems to make sense. If this guy is 37, this guy is 37. So that one's pretty easy. It just makes an isosceles triangle. So you should be happy when you see that you have a 45-45 because that makes life so much more straightforward. These two sides will automatically be equal. That's why they're both marked with an X. This long side is always going to be whatever the short side is times the square root of 2. So your hypotenuse is always going to equal one of your legs times the square root of 2. Every time. That you don't have to do any adding, you don't have to do Pythagorean theorem, you just have to know this ratio. Okay? So when we take that then, and once again, my mouse does not want to click unless I've got it right here. And so we can set ourselves up a chart to help ourselves keep track of what we have. And so you say, okay, one of the angles is 45, however long it is. Another angle is 45, it's going to be however long it is. And then the 90 degree will be root 2. If having the x's here is going to confuse you, I like to just say the 45 degree side is a leg, another side will be another leg, and then the 90 degree angle is going to be opposite the side that is the leg times the square root of 2. And so this is a 45 record, this is a 45 record, and this is one that's in a square box. So that's to help you remember how it looks. Okay? And so what I want to do is go through a couple problems and show you how we can use this then to find the sides of triangles. And so looking up here at this first guy, you see that, oh, I have a right angle here. These two guys are congruent. Well, you know then if those two angles are congruent, they must automatically both be 45 degrees in that right triangle. Well, if they're 45 and 45, I know that these two sides right here are automatically going to be congruent. They're the same length. And then this side is my hypotenuse, and they tell me that it's 5 times the square root of 2. And I want to know how long the two short sides are. And so I'm going to go through here and say, okay, this is one leg, this is another leg, and this will be a leg times the square root of 2, whatever it is. Well, I know that the side opposite my 90 degrees is 5 root 2. And so what I do then is I take this chart and I say, okay, this 5 root 2 is equal to a leg times the square root of 2, because that's what it says right here in my chart. And so I use that to then solve this. How can I find out what just a leg is by itself? Well, it's times by the square root of 2. To get rid of a multiplying, we divide. So I'm going to divide off that root 2, and I'm going to divide off that root 2. Well, the square root of 2 divided by the square root of 2 cancels out. And this square root of 2 divided by this square root of 2 cancels out. And I'm left with 5 equals one of my legs. So this leg could be 5, and this leg could be 5. And now I have all three sides of my triangle using the special 45-45 right relationship that uses the square root of 2. Okay. Over here, I have really complicated shape almost, it seems like. And I have two sets of right triangles, and I am told that this side is 9. Well, it is one of the two sides of, this looks like a square, huh? And so I'm going to go with this as being a square. And so this side is 9. This would be one of my legs because it is not opposite the 90, it is opposite one of the 45s. So one of my legs here is 9. Well, that tells me my other leg should also be 9. So this leg is 9. And, oh, this leg is 9 and this leg is 9 because the whole thing is one big square. Now, this one is a leg times the square root of 2. And so how would I find out how long y is, this diagonal, the hypotenuse of this triangle? Well, I know that my leg times the square root of 2 will give me this mystery. I shouldn't have put a circle there. I should have left a blank there. So my leg times the square root of 2 should give me this. Well, I know that my leg is equal to 9. So my mystery side is 9 square roots of 2. And I can fill it in there. Down here, got some junk in the way. I've got x and I've got y. So my hypotenuse is 2 root 6. And so it's going to be the leg times the square root of 2, and it's going to be 2 root 6. One of my legs will be x. Another of my legs will be y. And I'm going to find them both now. So I'm going to say, okay, I know that a leg times the square root of 2 equals 2 times the square root of 6, because that's what I found in my picture. My hypotenuse is 2 square roots of 6. And so I'm going to take this equation and I'm going to work it out. So I'm going to say, okay, I want to get a leg by itself and find out how much these are. So I'm going to divide off the root 2 and I'm going to divide off the root 2. Those cancel and I'm left with just a leg, and now I have to work this problem. And so this is where what we learned with the rules for radicals is going to help us. I've got 2 radicals here, so I've got 2 root 6 over root 2. Okay, well, remember when we do the radicals, we can divide the radicals. So root 6 divided by root 2 is just going to be the square root of 6 divided by 2. Well, that's, the 6 divided by 2 is just 3. So my leg, that got way too crowded. I'm going to bring this over to this empty. Nope, I don't have room over there. Let's come up here. So my leg will equal 2 times, and the root, and 6 divided by 2 is 3. So one of my legs should be 2 root 3. So, oh look, this leg can be 2 root 3, and this leg can be 2 root 3. And that covers both my x and my y being the 2 times the square root of 3. I'm going to clear some space here so that you can look on this last guy now. So over here, I've got a 45, 45 right triangle, so I can say that one of the short sides, x, that's one of my legs, I'm going to call it x. One of my other legs is going to be, 7 times the square root of 2. And my 90-degree side, the hypotenuse, they didn't tell me. It's just y. And so I'm going to try and find what I'm missing. Well, look, my leg is equal to 7 times the square root of 2. Okay? Well, this side here, you pick a side you're trying to find. This leg just says x should be the length of a leg. And I know that a leg is 7 root 2, so this leg should be 7 root 2. The tricky part is when we get here. My y should equal a leg times the square root of 2. And you go, okay, how much is one of my legs? Well, my legs are both 7 root 2, but then a leg will have an extra root 2 hanging off of it when I find my hypotenuse. So let's see that again. Let's see what happened there again. I'm going to erase it and do it all over again so you can see it. I know that my y is going to equal to a leg times the square root of 2. And then I'm going to substitute for my leg however long a leg is, which is 7 root 2. So yes, I end up with 2 radicals in the same problem that are multiplied, but I can do that. Y is going to equal 7 times the square root of 4. And then you think, oh, I know what the square root of 4 is because it's a perfect square. The square root of 4 is just 2. So y will equal 7 times 2, and y comes out to equal 14. So down here, I now know that y is 14. And so I've used all my numbers to find each of the 3 sides. So this is why we learned those rules for radicals, was so that we could use those amounts to find some of these. And so now I did all that on the board, but I forgot that I had these clickable, so I just have to click through some of these to get them off and move on to the next thing. So our second special right triangle is a 30, 60, 90 right triangle. So in this case, when you have the right angle, if one of the remaining acute angles is 30, then the other one has to be 60, because 30 plus 60 is 90, plus 90 is 180. So a 30, 60, 90 right triangle also has a special relationship between the sides. Now, if you recall, the smallest side is always opposite the smallest angle. The smallest angle is 30, so this is my smallest side. And I'm always just going to stick around and call him small, because he's opposite the smallest angle. My middle angle is going to be opposite the middle side. It's going to be opposite the middle size side, and so the 60-degree angle will be opposite this guy. So this is my middle side, or my medium leg. Okay, so I'm going to call him medium. Okay, and then my hypotenuse will be the longest side no matter what. Now, the interesting relationship that these 30, 60, 90 triangles have is that the small side, we just always call him small, or x. The hypotenuse is always twice as big as the smallest side in a 30, 60, 90 triangle. So if this side is 10, the hypotenuse is automatically 20. If this side is 14, the hypotenuse is automatically 28. If I know my hypotenuse is 50, I know the small side has to be 25. That relationship always holds. So that's what the x and the 2x tells me. The medium side is special too. It uses another one of the radicals. And the way we always find this one is we take our small side, x, times radical 3, times the square root of 3. So this relationship is one you're going to have to try and remember somehow. I don't know how you're going to, but 30, 60, 90s have the small one being x, the hypotenuse is 2x, and the medium side opposite 60 is always x root 3. To set that up, we like to use this chart again, where we go, okay, I have my small side is opposite the 30 degree. My medium side is always opposite the 60 degree, and it's always the small times root 3. My hypotenuse is always opposite the 90 degree angle, and it's always 2 times that small side. So everything relates to this small side. The small side is itself, the medium side is small root 3, and the long side is 2 times whatever the small dude was. Okay? And so again, I have some example problems here. In this first triangle, I have the 30-degree angle is opposite the side of x. So I'm going to put that here and remind myself that the 30-degree side is the small angle. Then I know that the 60-degree side is going to be my medium angle, and it's always the small guy times the square root of 3. But I'm told that this medium guy is 4 root 3. So I fill that into my chart to know where to start my work. And then the long side, my hypotenuse, is called y, and it's always 2 times the small side. And so now I can use this to set up an equation that helps me solve it. So I need to go and find, well, how big is my small side? Well, here in the middle is the only number I have. And it tells me, and I know I'm off frame, but you can keep listening to my words, is that the small side times the square root of 3 equals 4 times the square root of 3. And so I just need to get this small guy by himself. To do that, I'm going to divide off the square root of 3 on both sides. Now this root 3 and this root 3 cancel out, and I'm left with my small guy. Okay, I'm just moving it over a little so I have a blank space. This root 3 and this root 3 cancel out, and I'm left with it being 4. So my small side is 4. So here, my small side will be 4. X equals 4. My y should be 2 times that small side. So 2 times the 4 will give me 8. And I know that that one equals 8. So it's really important that you keep track of which part you have and what you're calling things. That's part of why I cover up this x here and just say small root 3 and 2 times small, so I don't mix up, am I finding x, am I finding y? I just focus on the small side and then figure out what letter it was asking for in the end. Okay, so I'm going to erase just some of that junk so it's not too messy and move over here now. So this right triangle now, I've got my smallest side is 7 root 3 because it's opposite the 30-degree angle. So my small side is 7 times the square root of 3. So the medium-sized one opposite the 60-degree angle, this one better be the 60, that's x, and that's equal to the small side times the square root of 3. This is why I don't like these little x's in here, because I get confused. Am I finding x or is this x? And so I say small root 3, and 2 times the small guy, so I don't lose track of my letters. So my small side times the square root of 3 will tell me x. And then my 90-degree angle, my hypotenuse, is going to be y, and it's twice my small side. So if I can find out my small side, I can find these other 2 letters. So I come here where I have a number, and I know my small side is 7 root 3. To find my medium guy, so x is going to equal my small guy times the square root of 3. Well, let's replace the small guy with how big he is. Well, the small guy is already something with a radical, 7 root 3. And now I have to times it by root 3 to get x. So I'm going to take root 3 times root 3, and that equals 7 times the square root of 9. But the square root of 9, aha, that one's a perfect square. I can simplify that, and the square root of 9 is 3. And so 7 times 3 will give me x being just the plain old boring 21. Funny how that worked. Now to figure out my 90-degree angle, give myself a little space here, I'm going to take my 90-degree angle is y, and it equals 2 times my small guy. Well, once again, I'm going to replace the small guy with whatever I figured out my small guy was, which is 7 root 3. And so y will equal 2 times 7 is 14 root 3. So y is 14 root 3. So now I know x is, the small guy is 7 root 3, x equaled 21, and y equaled 14 root 3. Okay? So down here, I have my small guy opposite the 30. I have small root 3 opposite the 60, and 2 times the small guy opposite my 90. Let's see what numbers I can plug in. Once again, conveniently, they gave me the small angle. It was 30. 30-degree angle is opposite the 12 root 3. The guy opposite the 60-degree angle, here's the 60, so that's my y over here. And then my hypotenuse has been labeled as x. And so once again, I set up an equation. I need to find the small guy in order to find x and y. So I'm going to come over here and do some work to find it. Let's see if I can angle this a little way. So I go, okay, if my small guy is 12 root 3, to find this guy, y, it's going to equal my small guy times the square root of 3. Well, my small guy is 12 root 3. And I plug it in here right next to this root 3. So now root 3 times root 3 is going to equal the square root of 9. Well, the square root of 9 is just 3. And so 12 times 3 will be 36. And I have found my medium guy now. To find this large one, come up here and do some work up here. I keep jumping all over the place, don't I? So to find x, I'm going to take 2 times whatever the small angle was. Well, the small side equaled 12 root 3. So x will equal 2 times 12, which is 24 root 3. And you have found your third side. And so you have all your numbers here set up, and then you can plug them straight in. Okay? So setting up this chart and learning what these amounts are is going to really help simplify what you do. So one more example here now. I need to find this x and this y. And so I'm given that this 30-degree angle is opposite a side of 5. So my small angle is opposite the 5. This y is opposite my 90-degree angle. So it's my hypotenuse. This is y. And it equals 2 times my small guy, just like I've always been talking about. So to find y, I need 2 times the small angle. Well, I was told that the small angle is 5. Or I keep saying angle. The small side is 5. So y is going to equal 10. Okay, so I can put that in here. Well, now I have the problem of how am I going to find x? And so, oh, look. I have arrows telling me that these are parallel lines. So I'm going to erase a little bit of junk here and erase some junk here because I found that this guy's 10 now. I go, oh, if this is parallel, that means this is a transversal, and these two angles are alternate interior angles. Alternate interior angles are always congruent. So this angle right here is 30. This one is 90 because we have a rectangle, which makes this guy 60. So this x side now is across from my 60-degree angle. So now I am looking for this 60-degree side x. I get him by doing my small side times the square root of 3. But I have to focus on this new triangle now and say, okay, which is the small side? Do I know how big my small side is? I don't. It's a mystery. But I know that my hypotenuse is 10. Okay? And so, oh, if I know my hypotenuse is 10, that's equal to 2 times my small side. And so if I divide off that 2, 5 is how big my small side is. So my small side here is now 5. Well, that didn't help me find x. That found me my small side here. But now I can use that my small side was 5 to find the medium guy, because I know my medium guy is x, and x equals the small times the square root of 3. And we just found that my small guy is equal to 5. So I plug it in, and I go, okay, so x should equal 5 root 3. Okay? So you're going to be practicing setting up these charts and finding the different sides in them in order to be able to find the third side of our special right triangles. And I was looking for my mouse here. So if I go and click in here, This is, ooh, look at that. It did something goofy here. I don't want that. I want my arrow. That's okay, because I'm going to exit my full screen anyway, because I'm done with this slideshow. And instead, I just want to show you a little bit in what the notes are in class. So in here, we just put this reminder thing, and this is available for you to look at. Okay? And so there are some practice problems in here to remind you how to simplify your radical and stuff like that. So there is a filled in copy of this in your drive with some more example problems for you to do that you can go through, but just remind yourself that for 45, 45, 90, you're going to have the small side, another small side that's the same, and your hypotenuse. This is always a leg, this is always a leg, and this is always a leg times the square root of 2. If you can keep this straight, then you can fill in what you're given below it and set up equations that will solve for your third side. For your 30, 60, 90 triangles, you have this, you're going to have the same thing happen. Okay? So if you have a 30 and a 60 and a 90 in here, okay, and I know it's kind of dim, but you can find this printed in your drive and available for you in the module. Okay? So for 30, 60, 90, remember the side opposite the 30 will be your small side. So that side across. Your side opposite your 60 is going to be whatever your small one was times the square root of 3. And then your hypotenuse is always going to be your small side times 2. And so those are your setups to help find the special sides of right triangles. Thank you very much.